Good morning, my dear students. My name is Nirpayana BSc. Currently, I'm available at the Hamlet Tuition Center, Brahmatul, Kathmandu. My contact number, if you want to contact me, is 9849135739. And I'm also available at Kumudini Kunja Secondary School, Kalimati, Kathmandu, established in 2036 BS, and it has dedicated itself for knowledge and wisdom since then. Well, my dear students of grade 9, we have been studying about lesson sound for previous since previous 2 weeks, isn't it? Okay, up to our previous class, we discussed about reflection of sound. Yes, and in reflection of sound, there were two phenomena that we discussed: echo and reverberation. Okay, echo and reverberation. Okay. Today we are going to discuss about refraction of sound. Okay, refraction. Well, you are well familiar with the term refraction. Okay, what happens in refraction? Refraction is also a phenomenon of wave, a property of wave. Okay, generally, let's see in this figure. Let's see, this is a light ray or sound wave. It could be anything. Okay, I said refraction is the property or phenomenon of wave, not of light, not of sound. Okay, this is a wave which usually is transmitting in straight line. Okay, this wave is transmitting in straight line. Suppose there is no change in medium. Okay, there is no change in medium, so this is transmitting in straight line. However, if it happens to enter into another medium, if the light ray or sound wave happens to enter into another medium, then what happens? The two medium do not have same density. The two medium may not have same density. Because of that, the velocity of wave changes. Okay, whenever a wave changes a medium, its velocity changes, and because of that change in velocity, it does not continue in this straight line path. It cannot continue its straight line path. It gets bent away. Okay, either bends like this, okay, or it bends like this. Understood? So this phenomenon of bending of light ray or sound wave, when it passes from one medium to another medium having different density, it is called refraction. Okay, refraction. In sound chapter also you discuss about the term refraction. So it is basically the same for both sound and light. There is no difference. Okay, look here. When sound transmits from one medium to another medium having different density, it bends. If the two medium has same density, then it does not bend. Okay, but if they have different density, then it bends. This phenomenon is known as refraction. As light, sound also follows the laws of refraction. Okay, now there are two basic rules. Okay, when sound travels from denser medium to rarer medium, what happens? And when sound travels from rarer medium to denser medium, what happens? Okay, let's see. If sound is traveling from denser medium to rarer medium, then you can see in the diagram, this is incident ray. Yes, incident ray, or you can also say incident wave. Incident wave slash ray. Okay, this is incident wave slash ray, and this is the surface of change in medium. Okay, and the point on surface at which incident ray strikes is called point of incidence. Okay, the point on surface at which the incident ray or wave strikes is called point of incidence. And right at the point of incidence, we can always draw a normal. Normal means perpendicular line, isn't it? We can always draw a normal. okay, which is indicated as n n dash. Okay, n dash. Okay, any confusion? Well, this is O. O means what? O means orange? No, O means point of incidence. Okay. Now, okay, what is happening here? I showed you here. You can see I showed you the path of wave or ray if there was no change in medium. If there was no change in medium, but if there is change in medium, this light ray, it will have to bend. It bends. Now, in what way will it bend? I already told you there are two possibilities. Either it might bend like this, okay, or it might bend like this. Yes, so when it bends like this, we say it is bending toward normal, isn't it? It was here, but its affinity is toward normal. It is moving toward normal. However, in opposite case, in contrasting case, it might bend opposite to normal. Normal is in this direction. Yes, this is its mean position. Normal is here, so it would move to other direction. So there are two possibilities. Now, in which direction or in which way does this light bend? Well, when light ray or sound wave enters from denser medium to rarer medium have less density. Means both light and sound will have greater velocity in rarer medium. Okay, it has greater velocity, which means it will bend away from normal. Understood? It will bend away from normal. Okay, okay, now let's see another case as well. Okay, in second case, the wave or ray is transmitting from rarer medium to denser medium. It is transmitting from rarer medium to denser medium. Now, when it moves from rarer to denser, then obviously its velocity will decrease. Okay, so it will even its inclination will even decrease. Okay, that means it will move toward the normal. Okay, when sound wave or light ray travels from rarer medium to denser medium, it bends toward normal. Okay, see here. Okay, this is it. When sound travels from denser medium to rarer medium, it bends away from normal, and when sound travels from rarer medium to denser medium, it bends toward normal. Okay, any confusion? Okay, now let's discuss about a case regarding which is related to reflection of sound. Well, sound is heard much farther during night than day. Why? Okay, this experience, you might have had this experience. Okay, दिउँसोको टाइममा साउन्ड तिमीले बोलेको साउन्ड धेरै परसम्म जाँदैन, तर राति साउन्ड धेरै टाढासम्म जान्छ. ओके, ओके, दिउँसोको टाइममा एकचोटि कौसीमा गएर हेर कहाँसम्मको साउन्ड चाहिँ तिमी सुन्छौ, र रातिको टाइममा कौसीमा बसेर हेर कहाँसम्मको साउन्ड तिमी सुन्छौ. देयर इज बेसिक डिफरेन्स. इभन मेरो घरको कौसीको कुरा गर्ने भने म डल्लुमा बस्छु. Okay, it is well known fact that sound is heard much farther during night time than daytime. And why is that? This is very common question and the most difficult one as well. Okay, well, it is because of refraction of sound. Okay, refraction ले गर्दाखेरि यस्तो हुन्छ भन्यौं है. अब refraction ले कसरी चाहिँ साउन्ड टाढासम्म ट्राभल हुन्छ त्यो एकचोटि राम्रोसँग डिटेलमा बुझौँ है त. यो सोर्स अफ साउन्ड भयो है, अनि ग्राउन्ड लेभल भयो. ड्युरिङ नाइट टाइम, हामी नाइट टाइमको कुरा गर्दैछौँ. ड्युरिङ नाइट टाइम के हुन्छ त, ग्राउन्ड चाँडै चिसो हुन्छ है, जमिन चाँडै चिसो हुन्छ. भएपछि जमिनको नजिकैको यो जुन लेयर अफ एयर छ यो पनि के हुन्छ त, कम्पेरिटिभली चिसो हुन्छ. र यहाँबाट तिमी जति माथि अप्पर लेयरमा जाँदै गर्छौ त्यति नै त्यति नै तिम्रो एयरको टेम्परेचर बढ्दै जान्छ है एयरको टेम्परेचर बढ्दै गएपछि डेन्सिटी के हुन्छ र डेन्सिटी घट्दै जान्छ टेम्परेचर जति बढ्दै जान्छ डेन्सिटी घट्दै जान्छ ओके र डेन्सिटी घटेपछि के हुन्छ हामीले अघि पनि डिस्कस गरेका थियौं द लेयर विच हैज हाईएस्ट डेन्सिटी is considered as denser medium and the layer which has low density is considered as rarer medium. Okay, now see the lowermost layer of air acts as the denser medium, and as it moves upward the upper layer of air would be rarer medium. Okay, and when sound passes from this layer to this layer, in that case also the lower layer will be denser medium and the upper layer will be rarer medium, and subsequently the upper layer will be rarer comparative to lower layer. Okay, so it means this is the source of sound. Sound is produced from this source in all direction. Okay, among them the sound which is traveling in straight line is called direct sound. Okay, that does not undergo any kind of refraction, but we are talking about the sound which is traveling in upward direction. Okay. Now see at this interface. At this interface, what did we discuss? What did we say just now? The lower layer will be denser medium and upper layer will be rarer medium. Okay, what happens when sound travels from denser medium to rarer medium? What happens? Well, we discussed it. We have already discussed about the laws of refraction. Yes, when sound wave travels from denser medium to rarer medium, it bends away from normal. Okay, that's why you can see angle of incidence is less than angle of refraction. That means angle of refraction would be greater than angle of incidence. Okay, that's it is bent away from normal. See, normal is here, it is moving away from normal. Okay, now let's talk about another interface here. Here also same thing is happening. Sound wave is traveling from denser medium to rarer medium. Once again, what happens? The sound wave will move away. It will bend away from normal. That means angle of refraction will increase even more. So at each interface, what is happening? Angle of refraction is increasing. So at some point, angle of refraction would be close to 90 degree. Okay, angle of incidence also keeps on increasing and angle of refraction also keeps on increasing. At some point, angle of refraction approaches to 90 degree. Okay, and then if the light ray and if the incident ray if the incident wave falls to another interface, then in that case this angle of incidence is so great, that it cannot refract anymore, because for this value of angle of incidence, angle of refraction would be greater than 90 degree. Okay, angle of refraction would be greater than 90 degree. अब greater than 90 degree भएपछि लाइट रे के हुन्छ त यता बेन्ड नभएर फेरि तलै फर्किने भयो नि हैन त। हेर त यो 80 भनेको 90 डिग्री भयो, ग्रेटर देन 90 डिग्री भनेपछि तल फर्क्यो हैन। हो यो तल फर्केको लाइट रे अब यो इन्टरफेसमा के हुन्छ, इट इज ट्राभलिङ फ्रम रेयर टु डेन्सर मिडियम, so it will bend toward normal and it goes on like that and it returns downward once again, so it reaches the ground again. Understood? This is the process by which sound travels much farther during night time. Got it or not? Okay, हेर त यसलाई अब तिमीहरुले धेरै जसो स्टुडेन्टहरुलाई के हुन्छ भने बुझिसकेपछि पनि अब यो कुरालाई कसरी लेख्ने बुझ्न त बुझे, अब कसरी लेख्ने भन्ने कुराले पिरोल्छ के, जसले गर्दाखेरि उनीहरुमा कन्फ्युजन रहिरहन्छ है, त्यो डाउट रहिरहन्छ। ल हेर त अहिले मैले जति पनि कुरा बोले त्यही कुरा लेखेको छु। ड्युरिङ नाइट टाइम land cools faster during night time. As a result, layer of air near the land is cooler and have higher density. As we move to upper layer of air, temperature increases and density decreases. Okay, so lower layer of air becomes denser medium compared to upper layer. This is very important point. Okay, this is where the actual concept lies. When source of sound is on the ground, the sound that travels upward has to pass from denser to rarer medium, so it refracts and bends away from normal. It subsequently increases angle of incidence for the next layer of air. When refraction occurs again, angle of incidence increases after being refracted in each layer. At some layer, angle of incidence becomes more than critical angle. More than critical angle means critical angle is the angle of incidence for which angle of refraction would be 90 degree. And if angle of incidence is more than critical angle, then angle of refraction will also be more than 90 degree. In such case, sound undergoes total internal reflection. Okay, this word, this is a new word for you, isn't it? Total internal reflection. This is a new word for you. I'm going to highlight it. Okay, total internal reflection means it is a phenomenon of refraction, but it looks like reflection. Okay, look here at this point. At this point, what's happening? Since angle of refraction is greater than 90 degree, the light ray or the sound wave is returning to same medium. So what it looks like? It looks like it is reflected by this layer. Actually, this is not reflection. This is refraction, but it looks like reflection. Okay, that's why this phenomenon is known as total internal reflection. Okay, I'm going to write it here. Total internal reflection. Okay, this is it. Okay, don't forget the term. This is very important term. Okay, without this term you cannot explain this phenomenon. Okay, this is important point. So the sound bends downward, it then travels to the ground. Travels like gravel po bhais hai. Okay. Sometimes it happens. Yes. Okay, you बुझेको बुझेन हेर त यहाँनिर यो टोटल इन्टरनल रिफ्लेक्सन कै कारणले गर्दाखेरि चाहिँ साउन्ड डाउनवर्ड डाइरेक्सनमा ट्राभल हुन्छ र डाउनवर्ड डाइरेक्सनमा बेन्ड भएर यो ग्राउन्डसम्म फेरि फर्किन्छ. माथि गएको साउन्ड वेभ फेरि तल फर्किन्छ है. ओके, अब ड्युरिङ डे टाइमको हेरौँ है त. ड्युरिङ डे टाइममा के हुन्छ भन्दाखेरि ग्राउन्ड के हुन्छ? तातो हुन्छ. द ग्राउन्ड इज भेरी हट ड्युरिङ डे टाइम. ओके, बिकज अफ द्याट द लेयर अफ एयर which is right above the ground is hotter than upper air. Okay, that's why as you move upward, temperature keeps on decreasing. As you move upward, temperature keeps on decreasing. As a result, the lower layer of air will become rarer medium and the upper layer will become denser medium. This is just opposite to night time. See, during night time, lower air is denser and upper air is rarer. But during daytime, lower air is rarer and upper air is denser. So the sound wave which is traveling in straight line is called direct sound. Yes, that does not undergo refraction. There is no problem with that. That sound definitely you will hear, but very mild. Okay, now let's talk about the sound wave which is traveling in upward direction. See, at this point, at this interface, the sound is traveling from rarer to denser medium. And when sound travels from rarer to denser medium, it bends toward normal. See, it is bending toward normal. Okay, so here angle of refraction is lower than or less than angle of incidence. In next interface, angle of refraction further lowers and it approaches to 0 degree. And when it becomes 0 degree, it will move perpendicularly upward, and that sound wave will get lost in upper atmosphere. It will not return back. See, it's bending in upward direction. It's not bending like this. Okay, in case of night time, what's happening? In case of night time, it's bending like a curve. Yes, like a bow. It's bending and it's coming down. But during daytime, it's not bending, it's just moving upward. That is why during daytime, sound does not travel very far. Okay, that's it, my dear students, for today's class. This is all about the the lesson sound. In our next class, we'll start our new lesson, and what I suggest is you have textbook, whichever publication, it does not matter. Okay, you have textbook of science. Do the exercise from your book. Okay, from any textbook that you have, do the exercise of the lesson sound, and you need to send me the photo of your assignment in my messenger. Okay, that's all for today. Thank you, class.